In this important lesson, we're going to define slope and tangent to a curve at a point. And also, we're going to speak about the derivative of a function at a point. The derivative gives a way to find both the slope of a graph and also the instantaneous rate of change of a function. So the derivative gives us the slope of a graph and also the instantaneous rate of change for a function. So first, let's consider the slope of a curve at a particular point. I think we've seen this picture before. What we've done is we have taken an arbitrary curve, called it y equaled f of x here in blue, and we have called out a point, and the coordinates at this point are x naught and f of x naught. And what we do is we draw the secant line through this point, through this point P, and through this secondary point called Q. Now, Q is found by moving from x naught h units to the right. So the coordinates here at the point Q are x naught plus h and f of x naught plus h. Now, the slope of this secant line we can find using the slope formula. And then what we do is we investigate the limit of this slope as h approaches 0. If this limit exists, we call it the slope of the curve at this point P, and we define it to be the tangent line at point P. So let me see if I can show what we're talking about with respect to this graph. So what we do is we consider the limit of the slope as h approaches 0, as this distance gets smaller, and not just smaller, as h approaches 0, point Q is approaching point P, and these secant lines are approaching the tangent line. And so what we say is the slope of the curve at point P is the limit as h goes to 0 of the slope of these secant lines. This is how we write it. All right, so here's our definition. The slope of the curve, y equal to f of x, at the point P, which is x naught, f of x naught, is the number, the limit as h approaches 0 of, and then all of this is from the slope formula, but this is what you call the difference quotient, f of x naught plus h minus f of x all over h. The tangent line to the curve at, and this is supposed to say just at P, not PE, sorry about that, at P is the line through P with this slope, sorry about these typos, with this slope. There we go. Make sure you have that written down correctly. All right, this is awesome. What we want to do now is we want to use this definition to find the slope of a particular curve. So check this out. All right, find the slope of the curve y equal to 1 over x at any point x equal to 0, x equal to a, not equal to 0. What is the slope at the point x equal to negative 1, and where does the slope equal negative 1/4? Okay, so we have three different tasks here. So let's do the first one, which is find the slope of this curve at any point x equal to a. All right, so let's do it, and we're going to do this using our definition that we just wrote down. All right, so here's our definition. So the slope at this point, a comma f of a, will be the limit as h goes to 0 of f of a plus h minus f of a all over h. All right, so let's make some substitutions here. This is the limit as h goes to 0. So what we're going to do is we're going to substitute a plus h into our function. So this will be 1 over a plus h minus f of a. So that'll be 1 over a, and then all of this over h. I think what we should do here is get common denominators up here in the numerator so that we can actually perform this subtraction. the common denominator will be a times a plus h. This fraction here will have to be multiplied in the numerator and the denominator by a. This fraction here will have to be multiplied in the numerator and in the denominator by a plus h. So let me see if I can move this up here. All right, so then what we'll have is the limit as h goes to 0. What we'll have here is a minus a plus h, and all of this is over the common denominator of a times a plus h. Make that look like an h. All divided by h, which is equivalent to multiplying by 1 over h. Right? All right, let's move this down even further. So then this is equal to the limit as h goes to 0 of, let's see, negative h over this denominator times 1 over h. And now you should be able to see that these h's cancel out. And so you have the limit as h approaches 0 of negative 1 over a times a plus h. Now this denominator is not 0 at 0, and so at h equal to 0, so then this is just negative 1 over a squared. Because remember, h is approaching 0, so this term here is approaching 0. Okay, folks, this here is the slope of our curve at any point. That's really important that we understand what it is we just found. This is the slope of our curve y equal to 1 over x at any point within the domain of this function. Okay, now, what was the second question? Let's scroll back up. I don't mean to get you dizzy. Let's see. Find the slope. So we just did. It is negative 1 over a squared. And now what is the slope at the point x equal to negative 1? So now that we know what the slope is at any point, we can just substitute negative 1 into our expression for the slope, into this expression here. So now, then when a equals negative 1, the slope is negative 1 over negative 1 squared. Watch your signs. So this is negative 1 over 1. So then it is negative 1. The slope at the point or negative 1 is negative 1. All right, very good. Now, what's the second question? Let me box this because this was our answer for the second question they asked. Now they're asking us, I'm scrolling back up here. Let's see. Where does the slope equal negative 1/4? Okay, so then if they want to know when the slope is negative 1/4, that means they want to know when is this expression which defines the slope at any point for our function. When is this equal to negative 1/4? So to answer this question, let me scroll up just a little bit. What I'm going to do is I'm going to set this expression here, which again is the slope of our curve at any point. When is this equal to negative 1/4 is their question. All right, so now we just have to solve for a. All right, so we can cross multiply here, and when you do, you get a squared is equal to 4, right? Which leads us to two solutions for a, right? Either a is plus or minus 2. Remember that our curve is y equal to 1 over x. Let me write that down really quickly. Recall that this is our curve, right? So that means the 2 points at which, the 2 points on our curve where the slope is negative 1/4 is positive 2, comma, 1 over 2, and then the other point is -2, comma, -1/2. These are the 2 points on our curve where the slope is -1/4. Okay, folks, this definition is so important. So the derivative of a function f at a point x0, denoted f prime of x0 is, now here's the definition, f prime of x0 is equal to the limit as h approaches 0 of, and all of this is called the difference quotient, f of x0 plus h minus f of x0 all over h. And this is what we just used to find the derivative of a function at a point, right? We just did this. So this is the definition for the derivative of a function at a point. Now, I think it's important to remember that this definition, this derivative, has more than one meaning. It depends on the problem we're looking at. This derivative is the slope of the tangent line, right? But it's also the instantaneous rate of change with respect to x at a particular point. So just remember that it's the slope of the tangent line at a point, and also the instantaneous rate of change. All right, very good. Before we end this lesson, this is a good little summary of our discussion about the slopes of curves, the lines tangent to a curve, the rate of change of a function, and the derivative of a function at a point. All of these ideas are based on the same limit. This limit, as h approaches 0, of f of x plus x0 plus h minus f of x0 all over h. This difference quotient has 4 different interpretations. One, it's the slope of the graph at a particular point. It's the slope of the tangent line to the curve at a particular point. It's also the rate of change of our function with respect to x. And it's the derivative f prime of x0 at x0. All right, very good. I think this summary here is really, really good to have in your notes.